Hi guys, I just wanted to recap what we talked about today in class, kind of summarize, put it all together for us. So in class today we talked about a fictional family called the Addams Family with three members to the family: the Perky Patty Protons, the Nerdy Nelda Neutrons, and Enraged LED Electrons, and they all lived in a town called Matterville. In Matterville there was the Nucleus Arcade, and the Nucleus Arcade was surrounded by the energy streets. So we now know that this is just an analogy for an atom. So let's talk about the actual structure of an atom. We know that in the atom there is a nucleus that's at the center. This is surrounded by the electron cloud, broken into different energy levels. The subatomic particles are located inside those two regions. So we need to look carefully at where they're located. Which particles can we find where, and the details of those particles. So let's look at the subatomic particles. So looking at the subatomic particles, we're going to start with protons and neutrons. So protons have a positive electrical charge, right? So protons, positive. Perky Patty Proton had a positive personality. Their mass. Now, when we had the story, we said that they were large. When we're talking about subatomic particles, we're talking about very, very small pieces. So the scientists, when they first were investigating these, really couldn't figure out a way to find an accurate measurement. So they actually came up with a whole new measuring system and a new unit. That unit is called atomic mass unit. So when we're talking about subatomic particles and their mass, we're not going to measure them in grams, because try to stick a subatomic particle on a triple beam balance. It's not going to work. So we're going to talk about atomic mass unit. So a proton has an atomic mass unit of 1 AMU. Now let's look at the neutrons. Neutrons are neutral. Remember, Nerdy Nelda Neutron? She was boring. She was apathetic. She didn't care. She's neutral or no charge. They have a mass of 1 AMU, just like the protons. So they are really the same size. They're slightly larger, but for our purposes, we're going to say that they're the same size, a value of 1. So inside the nucleus, protons and neutrons both have a mass of 1 AMU. So the only difference between them is their electrical charge. A proton is positive and a neutron has no charge. Now let's talk about that electron cloud. The electron cloud, on the other hand, is really not tightly packed. It's mostly empty space. All those little tiny electrons are bouncing around in those energy levels. The electrons have a negative charge, right? So they have a negative electrical charge. Remember, Enraged Elliot was angry. He had a bad attitude. He had a very negative attitude. They are very, very small. Some scientists even like to say that they have no mass, but that's not right. They do have some mass. It's a very small mass. So we're going to assign it a value of 1 over 1,836 AMU. So what this means is it takes 1,836 electrons to equal the mass of 1 proton. So really what you need to understand, they're super small. They are the smallest of the subatomic particles that we're talking about. So as long as you remember that electrons are the smallest, you should be good to go. All right. Now when we envision what's actually happening, what we have to remember in an atom, you have negatively charged electrons bouncing around in that electron cloud, and they're orbiting that tightly packed nucleus. Now you notice I say here that the positively charged nucleus. Why do you think I say that the nucleus is positive? Think about who's in there. You've got a positive proton and a neutral or no charge neutron. Well, obviously the positive wins because this one does not affect the charge. Look at our overall atomic structure. So when we look at the atomic structure, this is what we're talking about. You see the positively charged protons inside the nucleus with the neutrons that have no charge. The negatively charged electrons are surrounding it and they're orbiting this nucleus. So our descriptions. We know the nucleus is positive, right? It's got a positive charge from the protons. It's dense. Those particles are tightly packed in. You see how little space they have. And this is where I find all the mass of the atom, Because remember I said it takes 1,836 of these to equal one of these. The electron cloud, on the other hand, has a negative charge. Well, why would it have a negative charge? Who's in there? Are electrons. So this area would be negatively charged. Now look at all the empty space in between. There's a lot of space in between there. So it's a fairly large area with very little particles in it. So it is much less dense and more empty. All right, gladiators, I hope this helps you remember the subatomic particles.